Welcome to C++ for Java programmers. I'm Professor Califf. In this video, I'm going to talk about strings in C++. There are two kinds of strings in C++. The traditional, or maybe old-fashioned kind, from C, that are often referred to as C strings, and the C++ library string class. In general, you will want to avoid using C strings whenever possible. The string class is much more flexible, easier to use, and not prone to buffer overflow problems the way C strings are. However, there are times when we can't avoid using them. The string class was a later addition to the C++ library classes, and so there are quite a few things that assume C strings, starting with our command line arguments. The good news is that it is very easy to turn a C string into a string class object, and the string class provides a method that lets us get the C string version of any string class string. So we can usually avoid working with our string data as C strings. Although we'll avoid using C strings much, it's a good idea to have some idea of what they are and how they work. A C string is just an array of characters where the intended string data is followed by a null character, which is written as \0. So here's a declaration of a C string with initialization that holds the name Jane. The resulting array would have the letter J, A, N, and E followed by the null character. We don't actually care what's in the rest of the array. We'll never look at it as we consider the array as a string. Whenever we're working with a C string, we interpret all data as the string until we reach that null character. So we have to have that null character, or we can end up reading all over memory until we get to a 0. In case you're not aware, the null character is simply the character whose ASCII or Unicode value is 0. I hope you can see why we consider C strings prone to buffer overflow problems. They have all the issues of any other array, plus we're counting on a specific value to stop us. Note that we also have to have room for the null character in the array. If I need to allow for a string of length up to 10, I need an array that holds 11 characters. It's also important to note that these are arrays, and so things that you wouldn't expect to work with arrays don't work here either. The assignment operator only works at declaration. We can't use it to copy C strings. Equals doesn't work for comparing C strings, and neither do any of our other relational operators. If you absolutely have to work with C strings, you'll need to use one of the C libraries that is available in C++, the C string library, which you can include with #include C string. It includes quite a few useful functions if you have to, as I said, work with C strings. So it has capabilities for copying, concatenation of strings, comparison of a pair of strings, finding the length of a string, and searching for characters or strings inside strings. So if you must, go look this up. I strongly encourage you to find a website that you like for looking at the documentation or looking at some documentation on the C++ libraries. I personally tend to use c++.com, but there are a few different sites that are quite reliable and have good information on them. Pick one of these and make use of it as you are working with C++. Before we move on to the string class, I want to mention another C library that's available in C++ that is useful no matter what kind of string you're working with, and that is the CCtype library. This is a set of functions that operate on characters and can be very useful. The functions that begin with is, so most of these, basically look at a character to see if it falls in a certain category. So is alphanumeric, is alpha, is blank, is control. Now note the declaration has int here and int here, but think of it as it returns a bool, though it can be any value. 0 will be false, anything else will be true, as always in C++. And you can think of this as a char. What we typically pass into it is a character. One thing to note as you're using these is to make sure that you understand what they're doing. So some of them it's really obvious. Is alpha Is it A to Z, either upper or lowercase? Is lower, is it a lowercase letter? But some of them may be less clear. The space is not a graphical character, so isGraph will return 0, but it is a printable. So isPrint would return non-zero. Most of these are fairly straightforward in terms of the basic idea: alphanumeric, alphabetic, blank, which does include both space and tab, does not include new line, is digit, 0 through 9, is graph, can be written, has a graphical component basically, is lower, is print, is the printable, which is basically the graphical characters plus the space, is punctuation, is space means is white space. So that would include things like the new line, tab, space, etc. Is upper, is uppercase. Is X digit is hex digit. So it's basically your 0 through 9 plus A through F. So that's the is. Then we have these two things that return a variation on the character. To lower, which returns the lowercase version of the character. To upper returns the uppercase version of the character. If it's already lowercase or already uppercase, it just returns that character. If it's not a letter, it just returns the original character. In some ways, the C++ string class is similar to the Java string class, but it's not immutable, so in some ways it's closer to string buffer from Java. And of course, C++'s ability to overload operators makes its string class much easier to use in some ways. Operator overloading means we can actually change the functionality of operators like assignment, equals, or plus for different types as easily as we can overload functions to work differently with different parameters in both Java and C++. We'll have a later video on how we can do operator overloading, but right now what we care about is that things like assignment, equals, and the index operator all work as you would want them to along with the other relational operators. So each of these will work as we would want and expect if name equals and, assuming name is a string class string, has the values capital A, N, that will be true. Otherwise, it will be false. If name at 0 is less than or equal to M, will be true if the character stored in the first letter of name is less than or equal to a capital M. Major is assigned preferred major. We'll go ahead and copy that data in. So all of a sudden, all of these things that we've had to worry about these operators don't work because we have references or because we have pointers, they work because operator overloading is a wonderful thing. Okay, so I want to just quickly run over some of the capabilities that the string class provides. The way we're going to use the string class is we're going to include string, and then we have all of these capabilities. We have iterators that will iterate through character by character. I don't see those used very often because we usually find it more convenient to just use the index operator and do a for loop, but we have that ability. We have a length and a size function. They're actually two different functions that both just return the length of the string. We have a clear that clears out the string, basically turns it into the empty string. We have an empty function that is basically an isEmpty. Is it empty? We have an at function that returns the character at this position. I don't see that used much. People typically just use the index brackets. We have a plus equal or an append method. Both work to add to a string. We have an insert of a character, erase a character, replace a character. We have find characters and strings, various variations of that, including find not any of these characters. So that's kind of cool. We have substring capability, as we have in Java. We have a compare function. We have the cstir function. So the C underscore stir is the way we're going to get the C string out of a string class string. So if we have a string class string and we need a C string for some reason, we can simply say the name of our string dot C underscore stir parentheses. Very simple. Then we have non-member functions. So these are not part of the class, but they are things that are overloaded to work with string class strings. So we have addition. The plus is overloaded to concatenate two strings. So I can say this string plus this string. We're used to that notion. Relational operators, so all of the less than, greater than, equal to, not equal to, etc. work fine. We have a swap that will swap two strings correctly, so you don't have to write the 3 assignment statements. We have the insertion and extraction operators overloaded so that we can do more easy input and output. And we have a getLine function that gets a line from a string into the string. So let's talk a little bit more about reading and writing string data. So writing, we typically just use the insertion operator. It's easy. We've got a string, just writes out whatever's in the string. The extraction operator works kind of like next in Java with the scanner. It's going to read word by word. So it will read until it hits white space, skipping over white space until it gets to something that's not white space. Pretty much just like next works with the scanner. We can read line by line with getLine. getLine is nice in that we can also specify a different delimiter. So if you want to read until you hit a tab, but you do want to include all white space, you can do that by using getLine and adding a third parameter, which will be the actual delimiter. There are two different versions of getLine, one with the string class string and one with C strings. So first here I have the string class string, an example. So getLine and then the input stream, so that could be CN or it could be a file, whatever it is we're reading from, and then the string to read into. And then if we have the delimiter, we'll have a third argument that would be the actual delimiter. But if we want to read until the end of line, until the new line, then we just use this. If we want to read in a line into a C string, we're going to actually be using a member function of the string because the string class is older than the string class. So it'll be input stream dot getLine at, and then your parameters will be the string to read into and the number of characters at most to read. We have to include this because, of course, we're going to have a limited buffer in which to read, and we want to make sure we don't read more than will fit in the array that we're storing that string into. Okay, while we're talking about I/O and string data, I thought it would be useful to do a quick look at character I/O options, because sometimes we really do want to read things one character at a time, or write things one character at a time. So we have a get method of stream that just reads in one character. We have a put of the output stream that will write one character out. We have a peek that is rather cool if you're trying to parse data, because it will look at the first thing in the stream and tell you what it is, but it doesn't actually remove it to the stream. So if you're trying to make a decision based on what that next character is, you can look at what it is, but leave it there if that works better for your logic flow. We also actually have a put back. So if I did read something, I can actually put it back on the stream. Now, depending on what kind of stream it is, that could end up with different sorts of behaviors. In general, you want to be putting back the same thing you just read, though there are circumstances where you could put back something different and have it work correctly. And then we actually have an ignore that takes a number of characters to ignore, and we can just ignore parts of our string, which can be quite useful in certain cases. Let's go ahead and experiment a little bit with strings. So let me pull up my environment here. And I have already created a starting point for us this time. So let me show you what I've got here. We'll see how that works, and then we will go on and experiment with a little bit more. So I have here string practice.cpp. I've included IOStream for input and output, CString because I want to play with C strings a little bit, CCtype so we can look at a few of those functions, capabilities, and of course our string class in string. And we've used namespace standard so that we can actually use all the names that we might be interested in. So what I've done here is I've got a main. I went ahead and included our command line arguments, and I'm printing them out. So the first thing we're going to do is just print them out, give us a sense of this. Then I've created a CString variable in which I've put Jane, and I've done something to print the various characters in Jane with spaces between them. Printed the length of the string, whether or not that first character is uppercase, whether or not it's lowercase, whether or not the second character is lowercase. Then I've done something to modify what's in names. So we added a T and also then added a new null character to make sure that we stop our string when we should. Then printed out the result of that. Looked at comparing it. Then I've started a little bit with a string class string. I set that to Jane as well. Printed the length and the size, both of which should be 4. And then finally printed a comparison of name2 to Jane. So let's see what all of that does first, and then we will take a look at some other things. So let's make sure that's saved. Come back over here, find test item, and we will compile and run. Now, here's something interesting. I just compiled this and ran it. We actually do have one command line argument already, no matter what. So the first command line argument is always the name of the file that got ran. What is the executable file we ran when we did this? Then we have the printout. It appears that the rest of the array wasn't printable. So we may play with that a little bit just to see what we can do to see what else is there. Sterling returned 4, which is good. Now, this is interesting. If we look at what we're seeing, is upper of capital J returned 256. That's true because it's not 0. There's no information about what value it's going to return except that it won't be 0 if it's true. On the other hand, is lower for the capital J is 0, which is encouraging, and is lower for the lowercase a is true. So then remember we added the T and added a null character, and Janet prints. So we can go in and just modify it that way if we want to. Then we have a check to see if name is equal to Janet, demonstrating that that does not work because it prints 0. Then we created our string class variable name2 and printed its length and size, both of which are 4. And then we tried doing that comparison of name2 equals Jane, and that does work. In fact, let's go ahead and demonstrate. This is interesting because These are not the same. But what if I actually took name and put it into, oh, well, no, it's not the same anymore because it's Janet. Let's get rid of the stuff that turns it into Janet. Let's actually change that to Janet so that we're, okay. Let's get rid of all the stuff that had to do with Janet. And we'll see that we actually do have the same thing. So the equals will actually allow us to treat this as if it were a string class string. Now let's actually try doing that the other way around and see what happens. I'm actually not sure what will happen. And even that you can see works. Because there was a string class string involved. Okay, I'd like to look at a few other things. So let's actually come in here and I'm going to fill this up. Make sure it fits. Okay. Let's print that. Then I'm going to actually insert the null. And compile and run this. And you'll see that all of this prints. Let's go ahead and do a couple things. Let's get a new line here. And then after this, let's actually print out the name again so that we're seeing exactly what's going on here. So we print Janet Lim. We replace the T with a null. The space LIM are still in the array. But when we print that as a string, all that it's going to get is Jane. Okay. I'll show a couple things. First of all, I just want to demonstrate that we do have command line arguments that can come off the command line. So let's just type a few things. you'll see what happens with the command line arguments is just like what happens with Java, where each item is taken and it is one of these strings. Now, I'm going to do here is type my name, and I want to demonstrate something that is only demonstrable if I actually then print these things. So as I said, what's going to happen with the extraction operator is that we're going to just grab the first word, the second word, and if we did another, we'd actually get the last word. Now I'm going to go ahead and replace this with a get line. CN name 2. And only print out name 2. And you can see that it successfully reads in the whole line, as we would expect for a get line, similar to next line with the scanner. Okay, I encourage you to continue this experimentation, see what you can do with it, play with these things, get comfortable with it, and thank you for watching. Next time I'm going to be talking about pointers, how they relate to references, and how they relate to arrays.